Hello dear students, myself Professor Dipali Jain from Department of Pharmaceutical Chemistry. Today I am here with the type of thermal analysis, that is differential scanning colorimetry method. Okay, so as we know, the thermal analysis, it is the branch of science or material science which deals with the study of physical and chemical changes occur in the material when we apply the different varying temperature. Okay, now let us see the history of DSC method. The technique was developed by E.S. Watson and M.J. O'Neill in 1962, which introduced commercially in 1963 at a Pittsburgh conference on analytical chemistry and applied spectroscopy. First, a diabetic differential scanning colorimeter that could be used in biochemistry was developed by P.L. Prevost in 1964. Now let us see the principle behind this DSC method. It is a technique in which the energy necessary to establish a zero temperature difference between the sample and reference material, which is measured as a function of temperature. Here, sample and reference material are heated by a separate heaters in such a way that their temperature are kept equal while these temperature are increased or decreased linearly. These measurements provide quantitative and qualitative information about the physical and chemical changes that involve endothermic or exothermic process or changes in heat capacity. As we know, the thermal analysis method is based on the physical and chemical changes of the material when we apply the temperature. Okay, so what type of endothermic and exothermic reactions occur? Let us see. First one is endothermic reaction. If sample absorbs some amount of heat during phase transition, then reaction is said to be endothermic. In endothermic reaction, more energy needed to maintain zero temperature difference between sample and reference. For example, melting, boiling, sublimation, vaporization, de-solvation, these are the method or reaction of endothermic. Now next part is exothermic reaction. If sample release some amount of heat during phase transition, then reaction is said to be exothermic. In exothermic reaction, less energy needed to maintain the zero temperature difference between sample and reference. Example for exothermic reactions are crystallization, degradation, polymerization. So this is the principle behind DSC method. It is widely used to measure glass transition temperature and characterization of polymer. So what is meant by glass transition temperature or phase? The temperature at which an amorphous polymer or an amorphous part of crystalline polymer goes from hard brittle state to soft rubbery state. So when the material converted from hard brittle state to soft rubbery state, that phase or state is known as glass transition state. Okay. So it is a basic difference between the differentiation between DT and DSC method. Same principle is involved. Only the difference is different type of heaters are used to provide the temperature for the sample and reference. Okay. So differential scanning colorimetry or DSC, it is a thermoanalytical technique in which the difference in the amount of heat required to increase the temperature of a sample and reference are measured as a function of temperature. Okay, so in the basic principle of DSC method is, here we measure the heat flow. Okay, when we apply the temperature to the reference as well as for the sample by using different heaters, here we can measure the heat flow. So next part is the instrumentation of a DSC method. There are 5 different types of DSC instruments are available, such as heat flux DSC, power compensated DSC, modulated DSC, hyper DSC and pressure DSC. Commonly used DSC instruments are heat flux DSC and power compensated or power compensation DSC. These two types of instruments are most commonly used. This is the basic difference between the heat flux DSC and power compensated DSC. So here we will see what is the difference. So first one is sample holder. In both instruments, sample holder is made up of platinum, aluminium and stainless steel. Okay, as you see, same for the power compensated DSC. Next one is the sensor. So in the heat flux DSC, temperature sensors are used, but in the power compensated DSC, we use platinum resistance thermocouple. In heat flux DSC, usually thermocouples which are same for the sample and reference. But in the power compensated DSC, separate heaters or thermocouples are used for the sample and reference. Okay. Furnace, one block for both sample and reference cells. Here, separate blocks used for the sample and reference for in the power compensated DSC. Temperature in heat flux DSC, the temperature difference between the sample and reference is converted to differential thermal power which is supplied to the heaters to maintain the temperature of the sample and reference at the program value. While in the power compensated DSC, the temperature differential thermal power is supplied to the heaters to maintain the temperature of the sample and reference at the program value. So these are the basic difference between the heat flux DSC and power compensated DSC. Now let us see one by one of this type of instrument. So this is the block diagram for heat flux DSC. Here you can see a single block is used where sample and reference containers are present with which is attached with the single thermocouple. Okay, but in power compensated DSC, this is the block diagram for power compensated DSC. Here separate blocks are used for the sample and reference and separate heaters are used. Okay, so this is the main difference between the heat flux DSC and power compensated DSC. Now we will see one by one of types of DSC instruments. So first one is heat flux DSC. Here it is the diagram or block diagram of heat flux DSC. Here you can see sample and reference container are present in the block, okay, or in the DSC cell. This is the heater which apply the heat or temperature, and it is the heat sink. Okay, now this sample and reference are connected with the thermocouple, and this thermocouple then connected with the detectors where signals are detected and it is forwarded to the recording system where temperature and temperature difference are recorded. So this is about the block diagram of heat flux DSC. Let us see the instrumentation. A chromel disc and connecting wire are attached to the underside of each platform, and the resulting chromel constant and thermocouples are used to determine the differential temperatures of interest. Alumel wires attached to the chrome discs provide the chromel-alumel junctions for the independently measuring the sample and reference temperature. In this diagram, you can see two type of containers are present, one for sample and one for reference. Here, chromel discs are attached to the sample container, and this chromel disc connected with the alumel wire and chromel wire. Okay, so this alumel wire and chromel wire here is for to produce or to connected to measure the sample and reference temperature. Okay. A separate thermocouple embedded in the silver block serves a temperature controller for the program heating cycle, and inert gas is passed through the cell at a constant flow rate of about 40 ml per minute. This consists of a large single furnace which acts as an infinite heat sink to provide or absorb heat from the sample. The advantages generally include a better baseline sensitivity and sample atmosphere interaction. The key components are the sample pan, which is typically made up of aluminium. It is connected with the lead. Okay, means here the lead is also used, which is combined with the reference pan, and reference pan is also made up of aluminium. Okay, the dynamic sample chamber is the environment of the sample pan compartment and the purge gas system. Nitrogen is the most common gas, but alternate inert gas is helium or argon. When using on oxidative atmosphere, air or oxygen are the gases of choice. Okay, so this is about the sample holder and purge gas system. Okay, the heat flux DSC, it is based on the change in temperature between the sample and reference. Here you can see it is the block of instrument where sample and reference container are present. It is attached with the thermocouple, and here we determine the difference between the sample and reference. Okay, In heat flux DSC, we can write the total heat flow, that is dH by dt, as dH by dt is equal to Cp into dt by dt capital T divided by d small t plus F in bracket capital T comma small t, where H is equal to enthalpy in joules per mole, Cp is equal to specific heat capacity in joules per kilo per mole, F in bracket capital T and small t is equal to kinetic response of the sample in joules per mole. Thus, the total heat flow is the sum of the two terms, one related to the heat capacity and one related to the kinetic response. Okay. Now, second type of instrument which is used in DSC method is power compensation DSC method. So, in this diagram, you can see separate blocks are used for the sample and reference by applying or attach with it different heater. Okay. In power compensation DSC, the temperature of the sample and reference are kept equal to each other while both temperatures are increased or decreased linearly. The power needed to maintain the sample temperature equal to the reference temperature is measured in power compensation DSC. Two independent heating units are employed. These heating units are quite small, allowing for rapid rates of heating, cooling, and equilibration. The heating units are embedded in a large temperature control heat sink. The sample and reference holders have a platinum resistance thermometer to continuously monitor the temperature of the material. Both sample and reference are maintained at the programmed temperature by applying power to the sample and reference heaters. The instrument records the power difference needed to maintain the sample and reference at the same temperature as a function of programmed temperatures. Power compensated DSC has a lower sensitivity than heat flux DSC, but its response time is more rapid as compared to heat flux. This makes power compensated DSC well suited for the kinetic studies in which fast equilibration to new temperature settings are needed. It is also capable of higher resolution than heat flux DSC. So all PCDSC are in basic principles the same, but one of the special PCDSC is photo DSC, where direct measurement of radiation flow occur under a light source. Okay, so in this both type of DSC instrument, most commonly used is power compensated DSC instrument. Small individual furnace use different amounts of power to maintain a constant temperature between sample and reference, and the advantage here include faster heating and cooling and better resolution. This type of cell with two individually heated with a platinum heaters monitor the difference between the sample and reference. Platinum resistance thermometers track the temperature variation for the sample and reference cells. Holes in the compartment lids allow the purge gas to enter and contact the sample and reference. Here you can see two types of inlets are available for the sample and reference where purge gas is emerged. Okay, there are physically differences between the heat flux and power compensated thermal analysis. The resulting fusion and crystallization temperatures are the same. The heat of transition is comparable quantitatively. So this is the heat flux and power compensation DSC. Here one block is used. Here separate blocks are used where separate containers are present. Okay. So for power compensation DSC, higher resolution and higher sensitivity research studies, absolute specific heat measurement, and it is very sensitive to contamination of a sample holders. Heat flux DSC, it is the use for routine applications. It is near and at a line testing in harsh environments. It have an automated operation and it's cost sensitive laboratories. Okay, so these are the difference points for the heat flux and power compensation DSC method. This is the typical DSC curve which is plotted temperature against heat flow. Okay, so here you can see some endothermic and exothermic reactions occur. So this is the glass transition state. Here TC means crystallization exotherm. This TM means melting occur, means it is the endothermic reaction. Okay, so these are the some types of exothermic and endothermic reactions which occur when we apply the temperature, and recording is recording after the signal is obtained, this graph is produced. The result of a DSC experiment is a curve of heat flux versus temperature or versus time. There are two different conventions: exothermic reaction in the sample shown with a positive or negative peak depending on the kind of technology used in the experiment. This curve can be used to calculate enthalpies of a transitions. This is done by integrating the peak corresponding to a given transition. It can be shown that the enthalpy of transition can be expressed using the following equation, that is delta H is equal to K into A, where H is the enthalpy of transition, K is the colorimetric constant and A is the area under curve. The calorimetric constant or colorimetric constant will vary from an instrument to instrument, and it can be determined by analyzing a well characterized sample with known enthalpies of transitions. So let us see the some factors which affect the DSC curve. Okay, so here instrumental factor and sample characteristics, these are the two main factors which affect the instrument, okay, or which affect the DSC curve which is required to analyze the drug. Okay, now we will see the one by one factors. So first one is instrumental factors. So there Fernand's heating rate, after that recording or chart speed, then Fernand's atmosphere, geometric of sample holder or location of sensors, sensitivity of the recording system, and composition of a sample containers. So these are the factors or instrumental factors which affect the DSC curve. Next is the sample characteristics, which involve how much amount we will taken for the DSC method, then nature of sample, then sample packing, solubility of evolved gases in the sample, particle size of the sample, heat of reaction, and thermal conductivity. Okay, so these are the factors or characteristic of sample which affect the DSC curve. Okay. Now, there is some experimental parameters are also present which affect the DSC curve, which include 5 points. First one is sample preparation, second one is experimental conditions, third one is calibration, fourth one is resolution, and fifth one is sources of errors. Okay. Now let us see the detail of these experimental parameters. First one is sample preparation. So sample types, in the sample types, the DSC can be used to analyze virtually and material that can be put into a DSC sample pan, which include films, fibers, powders, solutions, and composites. Okay, so in this format we will use the sample. When making quantitative measurements or verifying reproducibility, it is important to ensure good thermal contact between the sample and sample pad. So it is required that there is the good thermal conductivity. Okay, the physical characteristics of the sample affect the quality of this contact. When using powdered or granular samples, spread them evenly across the bottom of the pan to minimize thermal gradient. For solid samples, select the side of your sample with the flattest surface for contact with the pan. After encapsulating the sample, ensure that the pan bottom is flat. If it is not, then flatten it by pressing the pan button on a flat surface. Okay. So what is the requirement? So sample should be placed in the sample pan by in the flat manner. Okay. If you overfill a pan, then the heating or cooling procedures may cause the sample to boil out, buckle, or explode the pan. If you are using an auto sampler, and this occurs so that the auto sampler cannot remove a pan from the cell because of deformation or boiled out material, operation is halted until the problem is corrected. So it is necessary when we apply or when we place the sample into the sample holder, the sample quantity may be or it will be less, and it should be placed in a proper manner into the sample pan. Okay, therefore you should be reasonable familiar with the effects of heating and cooling procedures on your samples and pans. So there is some note we should be taken. The contact between the pan and the raised sample platform is as important as the contact between the sample and sample pan. The oils on your fingers can affect the results of thermal analysis experiments. Always use tweezers when handling sample pans and sample material. So these are the some points which should be taken, okay, when we use this DSC method. Now next one is the determining sample size. So how much sample we will use in this method? About 5 to 20 milligram of sample is used for the DSC experiments. If purity determination are to be performed, then sample size of 1 to 3 milligram are recommended. Refer to the table below to guide you when selecting the sample size and heating rates for your experiments. So even there is glass transition state, then if we use to determine this property when different type of sample size is mentioned. Okay, so for glass transition we require 10 to 10 and 20 mg. Okay, and heating rate is 10 to 20 degrees Celsius per minute. For if we determine the melting point, then sample size is 2 to 10 mg and heating rate is 5 to 10 degrees Celsius per minute. If we want to determine the kinetics of that sample, then we will use 5 to 10 mg of sample and 5 to 20 degrees Celsius per minute of heating rate. If we determine the heat capacity, then we use 10 to 70 milligram of sample and 20 degrees Celsius per minute. If we want to determine the purity of that sample, then we use 1 to 3 milligram of sample and zero point 0.5 to 1 degree Celsius per minute of heating rate. If we determine the crystallinity of or oxidative stability of that sample, then in this case we use 5 to 10 mg of sample and 5 to 10 degrees Celsius per minute of heating rate. Now next part is the selecting a sample pan. When we select the sample pan, on selection of the appropriate DSC sample pan and lead, it is very important to determine the element which should be used. Okay, the result you obtain from the use of DSC will be affected by your choice. So here is some example of material where we use to produce the sample pan, okay, such as aluminium, then gold, copper, graphite, platinum, then aluminium volatile, gold volatile. Okay, so these are the some materials which we will use for the preparation of sample pan. Standard DSC pan here mostly made up of aluminium, copper and gold. Okay, and cream pans are made up of aluminium, copper and gold, where standard pans are made up of graphite and platinum. So next part is the experimental conditions. So heating rate, samples are heated at a rate of 10 to 20 degrees Celsius per minute in most cases. Lowering the heating rate is known to improve the resolution of overlapping weight losses. Advances in the technology have made it possible for variable heating rates, that is high resolution TGA, to improve the resolution by automatically reducing the heating rate during periods of weight loss. Second system is purge gas system. So most commonly used gas is nitrogen. Okay. So whereas helium provides the best baseline. Air is also used when the condition is oxidation reaction. Vacuum may be used where the sample contains volatile components, which helps improve separation from the onset of decomposition, since the volatile come off at lower temperature in vacuum. For example, oil in a rubber tire products. Next point is calibration. Organic compounds have been recommended as a standard when studying organic material to minimize differences in thermal conductivity, heat capacity and heat of fusion, and it may be used predominantly at a temperature below 300 Kelvin. Okay? Goal is to match the melting onset temperatures indicating by the furnace thermocouple readout to the known melting points of standards analyzed by DSC. It should be calibrated as close to the desired temperature range as possible. It is use of calibration standard of known heat capacity such as sapphire, slow accurate heating rates and similar sample and reference pan weights. Calibrants such as which should contain the following characteristics. It should have a high purity, accurately known enthalpies, thermally stable, it should be light stable, then non-hygroscopic and unreactive. Okay, so these are the some characteristics of calibrants. Next point is the resolution. One of the most important performance characteristic of a DSC instrument is its resolution. This refers to the ability of the DSC to separate or resolve closely occurring thermal transitions. The resolution of a DSC cell is dependent upon its particular design properties, including the mass of the furnace, the temperature measuring system employed, and the response time of the cell. The resolution of a DSC is also a function of the given experimental conditions, which include purge gas system, sample mass, and heating rate. Enhanced resolution can be obtained using a helium rather than a nitrogen, air, or oxygen due to significantly higher thermal conductivity of helium. Lower sample masses can provide improved resolution over the larger masses. Slower heating rates will yield significantly better resolution than the faster rates. So these are some high resolution, moderate resolution, and low resolution. These are the graph which mention the resolution types. Okay. Now next point is sources of errors. So if there is errors occur, they may be because of calibration, contamination, sample preparation, how sample is loaded into a sample pan. Then next is the residual solvents and moisture, thermal lag, heating cooling rate, sample mass, and processing errors. Okay, so these are the some sources of errors in the DSC method. Next, what are the advantages of DSC? Instruments can be used at very high temperature. Instruments are highly sensitive. Flexibility in sample volume form. Then characteristics, transition or reaction temperatures can be determined. High resolution obtained. High sensitivity and high stability of the material. So these are the some advantages of DSC. Then next is the what are the limitation for DSC? It is generally unsuitable for two-phase mixtures. Difficulties in test cell preparation in avoiding evaporation of volatile solvents. It is generally only used for thermal screening of isolated intermediates and products. It does not detect gas generation and uncertainty of heats of fusion and transition temperatures. So these are the disadvantages of DSC method. Now let us see the applications of DSC method. It is used to determine the melting behavior of complex organic materials. Both temperature and enthalpies of melting can be used to determine the purity of material. It is also used for the measurement of plastic or glassy material, glass transition temperatures or softening temperatures, which change depending upon the temperature history of the polymer or the amount and the type of film material, among other effects. It also used to determine the crystalline to amorphous transition temperatures in polymers and plastics and the energy associated with the transition. This DSC method is also used for the crystallization and melting temperatures and phase transition energies for inorganic compounds. We can determine these reactions. Okay. Then it is also used for the oxidative induction period of an oil or fat. We are determine the oxidative induction period. It is also used as one of multiple techniques to identify an unknown material or by itself to confirm that it is the expected material. This method is determine the thermal stability of material. It is also used to determine the reaction kinetic of a material. So these are the applications of DSC method. It is also used to measure the latent heat of melting of nylon 6 in nylon spandex fabric to determine the weight percentage of the nylon, also used for the determination of exothermal energy of polymer cure as in epoxy adhesives, allows determination of the degree and rate of cure. Now next part is the question bank, which is useful for your study. Okay, so these are the some questions related to the DSC method, which include the principle of DSC method, then types of DSC instrument. Next one is write a short note on heat flux DSC. Next one is write a short note on power compensation DSC. Then differentiation between heat flux and power compensation DSC. Factors which affect the DSC curve. The name of the purge gas which is used in the DSC method. Then instrumentation of DSC method. Next question is the write down advantages and disadvantages of DSC method. Applications of DSC. Differentiation between DTA and DSC is mostly question is asked about the differentiation on DTA and DSC or DG and DSC. So these are the some questions related to the question bank. Thank you.